So welcome to all of you. Today we will see the Euler's method for solving the differential equation. Okay. So consider the differential equation dy by dx is equal to f of xy with initial condition f of x naught. This is x naught. F of x naught is equal to y naught. Okay. So we have to solve this differential equation for the values of y at x is equal to x naught plus rh. That means x is equal to x1, x is equal to x2, and so on. So how you get? So if r is equal to 1, we get x1. x1 is equal to, so we write this as y at xn is equal to, okay, xr is equal is equal to, okay. So that means x1 is equal to x naught plus h and so on. Okay. Okay. So we'll integrate this integration from x naught to x1 dy by dx is equal to integration from x naught to x1 f of xy dx. Okay. So now this integration is y x naught, that is y of x. Okay. So this is what, just to be right, this is y of x. This integral will be y of x naught to x1, and this is what this integration is x naught to x1, because we don't know here the function now. Okay. Okay. Now this is what, then y of x1 minus y of x naught is equal to x naught to x1 f of xy dx. Okay. So this is y1 is equal to y naught, y of x naught be y naught, okay, minus, this is plus now, plus x naught to x1 f of xy dx. Okay. So this will be your y. Okay. Assume that f of xy is equal to f of x naught y naught in closed interval x1 x2. Okay. So therefore y1 is equal to y naught plus x naught to x f of x naught y naught dx. Now x naught y naught is the point, it is a constant, so it will be what then? The y1 is equal to y naught plus f of x naught y naught integration of x naught to x1 dx. This is x1. Okay. So now this is what, y naught plus f of x naught y naught. The integration will be what? x naught x1. Okay. So this will be what then? Y naught plus f of x naught y naught into x1 minus x naught. Okay. Now what is your xr? xr is equal to x naught plus rh. So what is your x1? Your x1 is what? X naught plus h. So that is what? X naught minus this will be h now. It will be h now. Okay. So that means what here? This is your y1. Now y1 is equal to y naught plus h f of x naught y naught. Okay. So we get the value of y1 naught. That means what? Y at x1 now. We get the value of y at x1. Okay. So now, we'll solve in the second interval. In the interval x1 x2, in the interval x1 x2, we obtain y2 is equal to y1 is equal to y2 is equal to y1 plus x1 to x2 f of xy dx. So note that this is the first solution. Remember this. Okay. Now we'll do for the second one. So f of xy is equal to f of x1 y1 in x1 x2 is x1 x2. So it will be what then? y2 is equal to y1 plus f of x1 y1, f of x1 y1, and this will what? The integration of x1 to x2. So this y2 is equal to y1 plus f of x1 y1 x2 minus x1. Okay. Now see this. This is your x0. This is your x1. This is your x2. The each distance is h now. Each distance is h. So that means x2 minus x1 will be h now. So this is what? y2 is equal to h. y2 is equal to y1 plus h f of x1 y1. Okay. Continuing. Continuing. In this way, we obtain yn is equal to yn minus 1 plus h f of xn minus 1 yn minus 1 for all n 1 2 3 dot dot dot. Okay, so this is the formula. Okay, so only remember this is the formula. This is the Euler's formula for solving the differential equation. Okay, so we'll solve a problem, then we'll understand how to solve a problem by using the Euler's method. Okay, so we'll take a problem. This is the method. We have explained the method of solving the differential equation by Euler's method. Okay, so we'll take a problem. Solve dy by dx is equal to minus y with initial condition y of 0 is equal to 1 by Euler's method. Choose h is equal to 0.01. Compute y of 0.4. So 0.4, it will be very difficult now, so it should be the 0.04. Okay, solution. Given that dy by dx is equal to minus y with y of 0 is equal to 1. Y of 0 is equal to 1. This is 0. This x y of 0 is equal to 1. So therefore f of xy, we need f of xy. x0 is equal to 0, y0 is equal to 1, and we have given h is equal to 0.01. We have given h is equal to 0.01. Okay, so by Euler's method, y1 is equal to Euler's method. y1 is equal to y0 plus h f of x0 y0. So what is your y0? Your y0 is 1 plus h. H is what? 0.01. Okay, so f of x0 is 0, y0 is 1. Okay, so 1 plus 0.1 into f of 01 is minus 1. So this is what? 1 minus 0.01. So this is 0.99. So this is what? 0.99. So this is y1. Y1 means what? This is y of 0.01. Y of point, because what here? X1 is equal to 0.01. Because x0, so this is what? This is nothing but what? X0 plus h. Okay. So this value is 0.01. Value at 0.01. Okay. Okay. So we find next one now. We have to find 0.04. Y of 0.04. That we have to find. Okay. So now here what? X1 is equal to 0.01. Y1 is equal to 0.99. Then y2 is equal to y1 plus h f of x1 y1. What is your y1? So your y1 is 0.99 minus h is what? 0.01 plus 0.01 into y1. Y1 is what? 0.99 minus 0.99. So this is equal to I will write direct value of this one. 0.99 minus this is what? 1, 2, 3, 4. Actually this is 99. Okay. So 0.01 into 0.99 means it is 1 into 99 is 99, and then how many decimals are there? 1, 2, 3, 4. So 1, 2, 3, 4. Okay. So this. Okay. Now the value of this one, just I will write directly. This value is what? 0.9801 now. 0.9801. Okay. So now this is y2 means what? Y2 means what? Y of 0.02 now. Right? So you have to add this. So this will what then? 0.9801. Right? So this is what actually y2 means what? Y of x2. Y of x2. So x2 is what? X2 is equal to x1 plus h. Your x1 is what? This. So that means your x2 is what? 0.02. 0.02. Okay. So now here we got the value of 0.02 now. We want to find the value of 0.04. So we have to do 2 iterations. One more 2 iterations now. Okay. Now your h2 is what? Your h2 is 0.02. Your y2 is what? 0.9801. Okay. Then your x3. Then x3 is what? x2 plus h. That is 0.03. We get y3 then. Okay. So then y3 is equal to y3 means y of x3. Okay. So y of x3. So this is what? y2 plus h f of x2 y2. x2 y2. What is your y2? Is 0.9801 plus h is what? 0.01. And this is what? F of x2. x2 is what? x2 is 0.2. Your y2 is what? y2 is 0.9801. So this is what then? 0.9801 minus plus 0.01 minus 0.9801. Because what? Your f of xy is minus y. Okay. So minus y, it is independent on the x now. Okay. So now this will what then? 0.9801. This will be minus. So we write is what? 9801 then. We write the product 1 into this. And how many decimals are? This 2 and this 4, the 6. These are the 4 and the 6. You have to do right. Okay. So the value of this one, you can use the scientific calculator. You can find the value of this one as 0.9703. So this is what? Y of. This is y of x3. That is y of 0.03. Okay. So that is your y3. Y3 is equal to y of 0. Okay. So now your x3 is what? 0.03. So therefore x4 is equal to what? 0.04. Now we will write directly. Just you have to go on adding 0.01. You will get x1, x2, x3 and so on. Okay. x4. Your y3 is what? Y3 is what? 0.9703. So you have to find y4. Y4 means what? Y of 0.04, and then your problem will be over. Okay. So we'll find that. So y4 is equal to y3 plus h f of x3 y3. Very simple problem. Okay. So this is y3. We got just y3 is what? 0.9703 plus h is your 0.01. F of your x3 is what? Your x3 is 0.03. 0.03. Okay. So 0.03. 9703. Okay. So this is what? 0.9703 plus 0.01. This is minus 1. F of xy is minus 1. That means minus 0.9703. Okay. So if you find this, so this will what? 0.9703 minus, this will be the minus. So 9703. So 3 the 6 decimal you have to left. Okay, 6 decimal. And the value of this one, is 0.9606. 0.9606. So this is your y of 0.04. Y of 0.04. So this is your answer, and now your problem is over now. Okay. If they ask for 0.05, then you have to do one more iteration. Okay. So this is the end of the problem. Okay. So this is your required solution, y of 0. Okay. Okay. So we will do the another problem so that the idea will be clear to you. Okay. So we solve one more problem. Solve dy by dx x square plus y with initial condition if they do not mention with the initial condition directly, they have given this, so no matter, this is what? Y of 0 is equal to 1. This is the initial condition. By Euler's method, the method will be given to you. By Euler's method choose h is equal to 0.05 and compute y of 0.02. Okay. Solution. Given that. Okay. dy by dx x square plus y of 0 is equal to 1. H is equal to 0.05. 0.005. Okay. So take care of that one. Okay. So your x0 is 0. Your y0 is 1. Okay. So your f of xy is x square plus y. Your xy. So then your x0, x1 is what? x0 plus h. And that is what? x0 plus h. Your x0 is 0. So this is what? 0.005. So y1, that means y at this one you are finding this. So what is your formula? This is the y0 plus h f of x0 y0 f of x0 y0. So what is your y0? Your y0 is 1 plus your h is what? 0.005 f of what is your x0? Your x0 is 0. What is your y0? Your y0 is 1. Okay. So now this is 1 plus 0.005 f of 0 1 put x is equal to 0 and put x is here we have taken function x is equal to 0 and y is equal to 1. So this will be the 1. And the value of this one will be what then? 1.005. 1.005. So this will be what? y1, and this will be the y at 0.005. Okay. Now your x2 is equal to x1 plus h. So 0.005 plus 0.005 is what? point not 1 now. Point not 1. Okay, that is your x2 now. Okay, now your y2 now. Y2 is equal to y1 plus h f of x1 y1. Okay, so what is your y1? Y1 is 1 double not or double not 5. Okay, double not 5 plus h point double not 5. Okay, so f of y, directly write the value of this one. This is what x1 square plus y1 square. X1 square plus y1. What is your x1? X1 is 0.01 square plus y1 plus y1. Y1 just we have calculated. This is what 1.005. Okay, so use the scientific calculator. Directly type this. Directly type 1.005 plus bracket this square plus this. Just type as it is now along with the bracket. So you will get the value. You will get the value. This as 1.01 okay, 1.01. Okay, you get this value. Oh, this is not value. 1.0151. You get this value. No, this will not correct value. Okay, this is correct. This is the correct. 1.01. Okay, that is your y2 now. That is your y2. Now we find y3 now. For y3, so now your x3, x2 plus h. What is your x2? Your x2 is 0.01. You have to add this. This is what 0.015 now. Okay, that is your. Okay, so y3 is equal to y2 plus h f of h2 y2. Okay, so what is your y2? Your y2 just we have calculated. This is 1.01 plus h 0.005. Now this is what x2 square. What is your x2? Oh, here we have applied x1 square. What is your x1? X1 is actually this is what 0.05. 0.005. This is the correct. Okay. Now your x2 square is what? 0.01 square. 0.01 square. Okay. Now here we have made mistake. You want here what? X1. Your x1 is 0.005. 0.005. So here x2 is 0.01 square. 0.01 square plus y2. So what is your y2? Your y2 is 1.01. Okay. So just we will see what is the value of this one. Is if you calculate this value is 1.0151. Okay. So now this is your y3. Therefore what? Y of x3 is what? 0.015 is equal to 1.0151. Okay. So note this. Note this. Okay. You should note this. This is what y2. Y2 means what? So y2 means what here? Y of 0.01 is equal to what? 1.01. So note this. Okay. So now we have to find y of point. What you have to find? You have to find point not 2 now. Okay. So now this is y3 x3. So your x4 is equal to x3 plus h. X3 plus h what? So see, this is what 0.15. So 0.05. This is what 0. This will be 2. This is 0.02. So this is 0.02. Okay. That means this is your last iteration. This is your so to find y4 is your last iteration now. Okay. So y4 is equal to y4 means y of 0.02. So this is what? Y3 plus h, f of x3, y3. What is your y3? Just we have calculated, this is your y3. Okay, so 1.0151 plus h 0.005. Okay, your x3 square. What is your x3? It's 0.015 square plus your y3. What is your y3? 1.0151. Okay, just see here, this is your y3. Okay, so type as it is on the scientific calculator. This plus this bracket, bracket, bracket square plus this complete bracket. Okay, so you will get the value is 1.02. You check it. 02. Okay, so therefore now this is your final answer. 0.02 is equal to 1.02. Okay, so only this is the crucial part. Go on adding h. Okay, so if the value of h is not given, so suppose we have given this initial condition. Now this is the end. The problem is solved here. Now this is the end of the problem. Okay, we get a solution. Our problem is over. But see, if you have given this y of 0 is equal to 1, and suppose they want the value of y2 now, or y3 now, right? Or y2, suppose the value they want, find y2. Okay, h is not given to you. Find a y of 2 now. Suppose they have given this y of 2. So now don't directly find y of 2 now. Don't take h is equal to 2 now. So you have to choose h now, so that at least 2 or 3 iterations you should do. So what? So for this one, you will take the h as 0.5. So that what? Your x1, your x0 is what? Then 0. Your x1 will be 0.5. Your x2 will be what? 1. Then your x3 will be what? 1.5. And your x4 will be 2 now. Okay. So if they want, the value of h is not given, so choose h so that at least you can do the 4 iteration. Right? Choose the value of h such way that at least you can do the 4 iteration. Okay. So you can take h is equal to 0.5. So if you want to do more iterations, you can take the smaller value of h also. You can take h is equal to 0.1. So what you will get the solution. So you have to solve the problem. The problem will be the linear. Okay. So you can take h is equal to 0.1. But then the problem will be very longer. Okay. So you will get what? You have to take a if you take h is equal to 0.1, then you have to do the 20 iterations to reach y, to reach 2 now. So if you want to find y2, you have to do the 20 iterations. If you take h is equal to 0.1. Okay. So don't do that. So just to take the value of h is what? So 0.5. So that it is the value. Okay. So I hope that you understand it one, how to solve the problem by using the Euler's method. Okay. So only here what? The function is important here. Function is important. You have to evaluate this function. Okay. So this part is important here. So you have the scientific calculator. So the calculation is not difficult for you. But take the care of the scientific calculator. You are using the scientific calculator. If you give the wrong command to the calculator, you will get a wrong answer. So give the proper command to the calculator. Okay. So take the care of everywhere while using the scientific calculator. Okay. So I hope that you understand this one. Now we'll stop here. Thank you.